This is a presentation that I did at the Euroconference in 2025 on the history and foundations of SSM. So SSM really began with work that was carried out in the mid-1960s at Lancaster University. A postgraduate department of systems engineering was set up by Professor Gwilym Jenkins, who recruited Peter Checkland and Brian Wilson, some of the big names in this field, to really run a program action research. And the idea behind this program was to take the systems engineering methodology and apply it to the problems faced by managers in organizations. And they did this by setting up a consulting company within the university called ISCOL Limited that carried out hundreds of projects. And the work done here led to systems engineering being adapted into what we now know of as soft system methodology, SSM. Peter Checkland, who is again one of the giants in this field, described this process in a series of seminal books, from Systems Thinking, Systems Practice, all the way through to Learning for Action. And in here we have the description of SSM over the ages and how it's changed and transformed and adapted from that initial systems engineering starting point. You also have Brian Wilson's Systems, Concepts, Methodologies and Applications that goes into quite some detail around some of these projects in practice. And there's a page in here that looks at really what came together to create this approach. So you've got two strands of research and development that come together. In the 1900s, you have this idea of systems being involved, general systems theory that had its roots in biology and the natural sciences. And then from the 1940s, you have increasing complexity in human-made systems and more complex market environments that lead to development of systems engineering methodologies. So you have this idea of systems theory and systems engineering. And the application was trying to bring these ideas together into more of a social science and social context. So can you bring these kind of elements together to try and address real-world situations? Now in this paper, Operational Research in 7 Decades, Robert Dyson looks at operations research, which traditionally has been seen as a fairly hard quantitative mathematical discipline. And there's questions raised about whether softer research, soft operations, is a legitimate branch of OR, because there's no mathematical modelling involved. You have this development of techniques that are about problematic situations and trying to address and create problem structuring methods. All these terms that are very different from the traditional hard, routing or queuing sort of problems that operations researchers do. And Dyson and Francis O'Brien look into this in more detail. They conclude that there is strong evidence that soft OR is a legitimate subset of OR, and it should be something that's studied within an OR context. Now, systems thinking, systems practice lays out some of the ideas that led the development of these soft approaches in some detail. So we start off in the 16th, 17th centuries with the development of science. And the key attribute of science are these terms about reductionism, repeatability, and refutation. It has to be objective, it has to be something somebody else can do. It can't just be your opinion. Now, the scientific method has a huge amount of success all the way through into the 1900s on the restricted and unrestricted sciences. Because biology, physics, chemistry, it just transforms the way in which we understand the world around us. But then you have an increasingly complex social world. And so science also thinks, well, it can go off and address these sorts of issues just as effectively because it's done so well in these other sort of spaces. And so you have this development in the 1950s of kind of the concept of systems to deal with this complexity, and an engineering approach to analyze and understand complexity. So you can see in here that there's a series of system methodologies that develop from 1955 all the way through 1976 as we move into this idea of applying the systems approaches and systems engineering to these sort of problems. But there is a difference between scientific problems and engineering problems. And so it's worth just going through how we think differently about these. So with science, the purpose is to advance knowledge. It's to kind of create new knowledge. While with engineering, it's about accomplishing something, some kind of defined purpose. With science, we try to understand the structure of the world around us. With engineering, we try and create structure. We try and build things like bridges. With science, we ask, what is this? What is a thing? Well, with engineering, we ask, what are we trying to create? What is to be? And again, with science, it's have we learned anything? Well, with engineering, the test is, does it work? And so, with a engineering and technology lens, we are trying to direct action to a defined end. And we measure ourselves as, whether it's successful or whether it's a failure based on does it work. Now, when we start trying to apply these 1950s ways of thinking of systems engineering to a variety of problems that are hard and soft, this is really where the starting point is. So, what is hard systems analysis? Well, with hard systems, you have an objective. You're trying to get from A to B. So, for example, journey planning is an example of a hard objective. There are alternatives. You can take one route or the other. And there are costs and results for each system. One thing might be short, but you might need to pay a toll. Well, something else might be longer, but cheaper. And you can create a mathematical model of the variables that are involved in here. You can relate all the elements. And by running a model, you can then figure out which particular combination of resources is going to meet your criterion or your objective in the most efficient way. So these are problems that can be solved. And really, it worked really well when it came to problems like resource allocation for defense. Hard systems work fantastically in wartime. And so then you ask, well, if we take these techniques and apply them to problems that are post-war problems, like those faced by business managers, how do we, apply these techniques? So in 1965, you have this view that, well, a business is just a system. It's like, anything else. And so your job as a manager is to set up, run, and maintain systems. That's the definition of manager's job. And this was the starting point for Checkland's work in 1969. The job of manager is to set up, run, and maintain systems. So how do we do that? Well, we use a systems engineering approach. Clearly, that seems logical. So that the methodology of SSM was developed from 1969 to 72 with this kind of work. So going back to the literature, you can see in 1976, there is the system engineering world about, that is our starting point. This is the existing knowledge that is our starting point for the work that Checkland carries out. And one piece of that is Jenkins' 1969 model of the systems approach. So the loop really is a systems thinking practitioner will look at what sort of action to take in a business or industrial problem situation, and then use a sequence of actions. They'll analyze what's required, they'll design a solution, they'll implement a solution, and then look at solution practice and see how it goes around. So you initiate a project, you need to stage the project, you need to put the resource in place, do the analysis, design, implementation, and operate it. Okay. But obviously, how do you begin this? Well, this whole organizational problem is owned by managers. These managers need help with their problem. So we go and ask them questions to understand what the situation is. From that, we come up with the idea of a project. And that project requires, you need to go through approval stage. You need a business case. You need things that explain what's going on. And then with that business case, you put a team together with the resources that are required, with sufficient flexibility to get the job done and go around this loop. So you've got the idea for a project, you've got to sell the project now into these managers. They need to say yes or no. So say, well, we're going to do these things, we need these resources, we need this team, and we'll deliver this for you. And the manager have a choice of saying yes or no. Now, you'd think that if your business case was right and made money, they'd just kind of say yes, because that's all there is to it. But in reality, that doesn't happen. In reality, the process of decision-making with a managerial group is more about debate, bargaining, and battle for resources rather than just the payback is right, let's go ahead and do it. There's all this kind of politics and stuff happening in real-world situations that the systems engineering methodology just doesn't take into account when it's trying to look at how we actually make these projects happen. So systems analysis, again, works really well for complex hardware. If you don't have people in your problematic situation and you're just looking at machines, how to put them in order, it works really well. But when these social questions come in, when people come in, their views come in, somehow things don't quite operate quite as effectively. Because, well, for a start, what are you trying to do? What's your goal? When it comes to hardware problem, it might be fairly clear. But when it comes to social problems, it might be messy. The things people tell you might not be the things they actually want to happen. It's obscure, the way in which they want things to happen, the kinds of things they're trying to achieve. So if we look at, on the left-hand side, these social situations, the right-hand side, more, harder, objective situations, we have this idea of a problem situation rather than problem. It's a situation that some people consider problematic, not just solve this problem. We're looking at a way to talk to people and structure debate rather than efficiently achieve an outcome. The action research we do is reactive. We don't know ahead of time how we're going to approach something, so we're going to talk to people, and then based on what they tell us, we then react and adapt the way we're responding, rather than planning everything beforehand and then just coming in and doing it. And often we deal with unstructured problems, things that people don't fully understand, haven't clarified, rather than a structured, we have this problem, solve it please. And the analysis can head into many areas, rather than being constrained to a single space or situation. And sometimes the goals people set are unhelpful. If you have an objective goal that says get from A to B, that's quite helpful. But quite often you might be set a goal that says, well, in some of the work that I do, decarbonize the industry, but don't annoy anybody, don't ask anybody to change how they're doing things, but I want you to go off and help me decarbonize my business. So all this ends up with this idea that a company or an organization, this thing you're trying to change, it depends very much on the particular view you take of the organization. Who's in the room, who's looking at things, and how do they see what's happening. And that particular view will lead to certain logical consequences. If I see the world in this particular way, and I think we should do this, that, and the next, there is a logical flow to what I think. And so this is the starting point, this idea that if we understand how people view the world and follow through the logical consequences of how they think, that leads to the development of the 7-stage methodology in 1975. And that looks like this. So we start off with a problem situation that is unstructured. We then try and express the problem situation in some sort of a way that we can actually work with. This is all the real world. So there's this idea that there is a distinction between the real world and the systems thinking world. So in the real world, there's a problem, you try and express that. You then move into this systems world, thinking world, where you try and create a root definition. So this is sort of a single sentence that describes the systems that you're trying to work with. And that definition leads to building conceptual models. So models in your head that try and say, well, if the root definition says this is what we're trying to achieve, this is our purpose, here's a model for how we can achieve it. And you build that model in a way that's informed by formal systems concepts and systems thinking methodologies in general. But this is in your head. Then you use a conceptual model as a way to compare your thinking and the logical consequence of how you think with the real world as expressed out there, and identify the kinds of changes that are feasible and desirable. What can we do to make things better? And you take action to improve the problem situation. So SSM in 1972 and 1990 is a development of ideas from that system engineering process all the way through to perhaps a more nuanced approach over time. We start off in 72 with a very blocks and arrows approach. There's a methodology, there's the systems ideas, action research, and really we're trying to make an engineering model that helps us improve situations. By 1981, there's this understanding that isn't enough. We have these 7 stages, and we move from just a systems thinking approach to more of a learning process and a logical exploration of what's going on. The beauty of the 7-stage model is that it's easy to teach, and so it takes off. A lot of people are interested in that, and it becomes the foundation for a lot of work. And it says, well, we're trying to build working models rather than certainty. And you also have the development of constitutive rules, and these ideas that if you do SSM, you need to do it in this kind of way. By 1988, there is a recognition that the modelling by itself isn't quite enough. You can't just look at the situation, because say look at the logical situation itself, you kind of miss why people take action, and that requires two other streams of analysis: the political, who has power and how do they act, and cultural, how do we do things around here. And this gets talked about as analysis 1, 2, and 3. And by 1990, Chetland simplified the whole approach from 7 stages to 4 main activities. There is a perceived real world problem situation. By engaging with that, you select models of relevant purposeful activity. So these models in your head, you then compare the models in your head with reality and look at accommodations that will enable improvements to be taken. So it's a simpler approach that says stuff in your head, stuff out there, look at the two of them and see how you can improve the situation. Now, SSM has changed over this period, it's been refined, and so by 2006 we have the definitive account of SSM. This is, if you are doing SSM, this is the kind of thing you're doing. So first of all, you have reality, which is this flux of events and ideas. In that, in reality, you have situations. Those situations contain people. Those people have a perception of the situation, and they want to do something. They want to take purposeful action in that situation. And so to try to understand what's going on, you have to organize your approach to it as a learning process. And this starts by exploring the situation and constructing models of activity. So the modeling part is still really important here. You use those models to ask questions of the people in that situation, to find opportunities for action that you can take to improve the situation. So this is essentially the final form of SSM as described by Chetland. Okay, now because of the history and development of SSM, there's been work done on this previously, and so this Mingus paper in 2000 is quite important. In the 1980s, SSM grows up. A whole series of improvements come in, perhaps fairly minor, but they include things like the 3 E's: effectiveness, efficacy, and efficiency, the idea of kind of doing X by Y in order to do Z, and then, as I mentioned before, analysis 1, 2, and 3, and refinement of certain concepts. You also have this change from the 7-stage model to a simpler approach between sort of mode 1, mode 2 operations and development of certain rules. But there are some issues here as well that Mingus points out. So one of those is this critique that SSM is conservative. It can't bring about the kind of big changes that are required in the world around us. Chetland, unsurprisingly, disagrees with this. He says SSM is a learning system, and so there's no limitations to the kind of change that you can bring about. But change is actually a really tricky thing to think about. This is an interesting reference from David Lane and Rogelia Olivier that has a story, which actually was first described by Beer, where Emperor Ferdinand of Australia, if you're dealing with the Emperor, if they ask you disconcerting but clear commands, for example, the Emperor here says, I want dumplings, what are your choices? Well, you can either choose to serve them, bring the Emperor dumplings, or you can leave their service. This is a common refrain when you faced with power situations. When somebody powerful says, jump, do you jump another way up? Ask how high. The other problem, actually, SSM, Mingus recognizes that SSM has been extremely important as a discipline. It's reoriented soft OR, thousands of people have used it. But it maybe hasn't raised its full potential. And why is that? Well, perhaps it's because it's been fairly isolationist. So in particular, given that it's very flexible and open, almost all the learning has come from Lancaster's own SSM experience. It hasn't brought in learning from other areas and other work that's been done perhaps in adjacent fields. So, for example, as we recognize the need for political and social analysis, it's not enough to understand the situation. You have to understand who has power and how they do things in that situation. There is a lot of literature out there on the politics of what's going on. Well, the response to the SSM is to pick up on what is called here quite marginal work by Vickers in appreciative systems. And is this really the most useful way to try and develop SSM? There's another contention here which Menger says is perhaps unfortunate, which is that, and he also thinks it's a mistake, where Chekland argues that the word system, the modelling approach, is epistemological. It's a mode of conceptualizing. It's not ontological, as in it doesn't exist in the real world. You have the real world, and then you have these models in your head. And that is problematic, because really that reduces the power of systems thinking. If your thinking cannot make change happen in the real world, then what's the point of doing all this work? Going back to that engineering and technology viewpoint, we're trying to do something in the real world. We're not just trying to have pretty ideas, we're trying to make change happen. And this particular conception of the models in your head, and that's all they are, seems problematic. It seems to reduce the impact you can have. So instead, if you think of these systems concepts as necessary to explain the world, and things that genuinely explain what's going on, then they have more sort of power to help you take action. If you don't do this, if you just say that this isn't real, then it becomes just a game. It's something in your head, and you're just playing games rather than trying to really make change happen. Now, Chekland, in his kind of retirement speeches here, Reflection of 40 Years in the Management Field, takes a Parthian shot at the field and just tries to describe his kind of 40 years of work. So in here you have this idea that there's been a swing in OR over the 40, 70 years between holism and reductionism. So the idea of kind of systems concepts and the scientific, let's break everything down, into reductionist. And so in wartime you have to do things in a holistic way, things have to work together. But then as you come out of wartime and look at OR for managers, problems become much more reductionist. The field splinters into separate OR techniques for routing and queuing and logistics. And they become very mathematical and very focused on a specific way of doing something. Again, very powerful in their context, but you're moving away from holism. And that's not enough for some of these real-world situations where you're trying to work with managers. And so you then have the development of PSMs, or problem structuring methods, which are more around trying to enter into wicked situations and make improvements. And then Chekland argues that the next development here is Vickers' work on appreciative systems. And this is where SSM would go if he had carried on working with this. And he started to introduce some of these ideas. But really, we're sort of stuck at the PSM level and perhaps in the OR techniques in the literature in general. So if we think of OR as a problem-solving methodology, and SSM is kind of part of this, how would this sort of work? So again, we have this idea of reality is a flux. It comprises happenings and ideas that unfold over time. So if you're trying to make an improvement, again, use SSM as a methodology, as a subset of OR, then you focus the problem situation within that flux. There is something there that you want to try and work with. You define the situation, so what's actually going on there, and then the politics and culture. Who has power, how is it used, how do we do things around here. Now, a very important part of it, we ended up here because of history. Something happened in the past. So we appraise the situation's history and we go through what led us to this point. We understand that in order to define the possible changes that can be done. And again, we can build a number of OR techniques. We can bring in different techniques to try and define those changes. Are those changes desirable and feasible? Do we agree that these are good to do? And if so, then we can plan and define action to be taken and take action. So this is the route that Chekland follows to go from identifying a part of reality that needs our help and improvement, and then going through to taking action. And so to finish off, really, in this kind of process of reforming, of improvement, it's worth keeping in mind that what we're trying to do, we're not trying to make the world perfect, but we only want to try and make it a little bit better. That's the improvement that we're trying to get to.